Assalamualaikum. We are from Group 6 and now my group and I, which consists of Ainin, Maya, Izzat, Fatin and I, Zalhazik, will present process safety under the topic 1,3-butadiene. Next. So for the introduction of 1,3-butadiene. Next, 1,3-butadiene, also known as butadiene, has a molecular formula of C4H6. It's a colorless gas that is highly reactive and flammable. It is widely used in the production of rubber and polymer. Butadiene was listed on the hazardous substance as it can cause carcinogen, irritation and frostbite. Oxidative dehydrogenation of N-butene is a common process for producing 1,3-butadiene. The reactants are oxygen and N-butene, which are passed over a fluidized bed reactor at low pressure and high temperatures using metal ferrites and molybdates as catalysts. So next slide shows the initial PNID of 1,3-butadiene. So, the reactants are fed to the reactor before being compressed in the compressor. Then, the substance goes through 3 separators where the byproduct furfural is removed and then being distilled by 2 distillation columns. The oxidative dehydrogenation of N-butene is an exothermic reaction where heat is removed by steam for steam generation. The reaction yields and selectivity range from 70 to 90%, making it unnecessary to recover and recycle the feedstock. The substance used and produced from this process have been identified as hazardous materials that can affect society and environment. And butene is highly flammable and can form explosive mixtures with air. It is also a gas under pressure and can explode if heated. Additionally, it can contribute to air pollution by participating in photochemical reactions leading to the formation of ground-level ozone. 1,3-butadiene poses acute and chronic health hazards. Acute exposure can irritate skin and cause frostbite. Chronic exposure lasting months or years can cause limb and blood cancer due to its carcinogenic properties. It also contributes to ground-level ozone and smog, affecting water quality and aquatic life. Furfural is used in petroleum refining, fungicides, and weed killers. Inhalation causes coughing and shortness of breath, while higher exposures lead to pulmonary edema. It irritates skin, causing skin allergy and rashes. Furfural affects air quality due to its strong odor, leading to odor pollution. It is toxic to aquatic life, causing growth inhibition and mortality. Next, I will pass to the next presenter.
Okay, thank you, Zalhazik. So now moving on to the hazard and operability analysis. So HAZOP is a method to define hazards and issues in the industrial processes. So there are several steps that we need to consider when we develop HAZOP. So first, it is important for us to define the study goals and objectives. Then second, we need to break down the process parameters into small sections using all the guide words such as more, less, no, low, or high. And from there, we are able to define the causes and the possible consequences relating to the problem. And finally, we can write down all the findings and provide actions to be considered by the operators. And all the HAZOP analysis can be reviewed regularly to ensure safety. So as can be seen in this slide, this illustrates the HAZOP on membrane distillation column. So first process parameter is regarding the pressure. So when there is a low pressure, this is due to the fact that it has insufficient feed rate due to leakage at the phalanges or instrument connection. So the possible consequences towards these causes is reduced separation efficacy due to inadequate separation. So, in order for us to combat with this issue is by conducting inspection and rectification, the feed pump operation. And also, we must introduce process a pressure control system at the inlet stream. So the second one would be high pressure. So high pressure is definitely due to excessive feed rate. So when this is being taken lightly, it could lead to serious problem, which is explosion. So in order for us to avoid from this matter from arising, it is important for us to include the pressure relief valve into the system. So move on to the next slide, please. So now is relating about the second process parameter, which is the flow. So if there is no flow, it is possibly due to complete pipe blockage due to polymer formation. And when there is no flow, it disrupts the butadiene process, leading to inconsistent product quality, and there is a need for operation shutdown. So in order for us to avoid operational shutdown, we need to inspect and rectify the feed pump. So for less flow, it's definitely due to partial blockage due to the polymer formation. And this will lead to reduction of separation efficacy that leads to poor product purity. And from there, what we need to do is to inspect and rectify the partial blockages. So move on to the next slide. When there is more flow, this is definitely due to control valves that is being open, stuck at the open position. And if this method is being taken lightly, the potential consequences would be flooding in the columns tray. And what we need to do to cater with this problem is to verify the control valve position and operation. And the final process parameter is regarding the level. So when the level is low, it is possibly due to insufficient feed rate due to blockages at the feed stream. And it will lead to inadequate liquid holdup that reduces vapor liquid contact time. And what we must do is to include the low alarm level, LAL, to provide warning indication and when the column liquid level is at abnormal state. And we can also include level indicator and controller to assist the operator to monitor and control process effectively. So next slide. When the level is high, this is probably due to blockages at the top and bottom outlet streams. So this will contribute to column flooding. And similar goes to the high level, we must include level alarm high, LAH, and also include level indicator controller. So that is how we as a team conduct the HAZOP analysis. Thank you.
Thank you, Amy Sophia. Now I will present about hierarchy analysis, which is hazard identification, risk assessment, and risk control. Next slide. Okay, first let's look at the hierarchy form. So our company name is Cekal Energy Berhad, and our selected location is in the refinery process area. So this assessment was approved by Mr. Izzat Shafiq, our site manager, and was conducted by Mr. Zahazi as the operator, along with me, Ms. Fatira Haina, as the supervisor. Moving on to the detailed hierarchy analysis, we start with the first hazard identification in the operation of the refinery equipment. The primary hazard here is the mechanical failure, which can lead to the equipment malfunction, release of hazardous chemical, and injuries from the falling object. Our existing control include the regular maintenance and the use of the safety card. The likelihood of this hazard occurring at the rate 3 and the severity is rated as 5, leading to the high risk score of 15. So to mitigate this risk, we recommend to continue regular equipment maintenance, installing the additional safety card on the equipment, and providing the comprehensive training on the safe operation procedure. So our maintenance manager is responsible for implementing this work activity before the due date of 20 June 2023, and this action was completed. Next slide. Next, we address the chemical handling and transfer process, where exposure to the toxic chemicals pose to a significant risk. This exposure can result in inhalation of harmful fumes, skin contact injuries, and chemical spill. The existing control include using the proper personal protective equipment (PPE) and ensure an effective ventilation system. The likelihood of this hazard rated at 4 and the severity is 5, giving a very high score of 20. The recommended control measure include using appropriate PPE, ensuring the proper ventilation system are in place, and implementing a robust spill contaminate system. Our safety officer is in charge of this work activity before the due date of 15 July 2023, and this action was completed. So for the monitoring and control of process, the primary hazard is a process deviation, such as overpressure, temperature spike, and uncontrolled reaction. Currently, we have the automate control system and alarm in place as the existing control. The likelihood of the conference is rated at 3 and the severity is 5, leading to a high risk score of 15. To further reduce this risk, we recommend using advanced automated control system, installing and maintaining the alarm system, and conducting regular process audit and safety check. Our process engineer is responsible for implementing this work activity before 31 August 2023, and this action was completed. Next slide. Finally, we examine the heat exchanger maintenance, where exposure to the high temperature and pressure is the main hazard. This hazard can cause burns, equipment failure, and leaking. Our current control include the thermal insulation, pressure relief valve, and regular maintenance check. The likelihood is rated at 3 and the severity at 4, resulting in the medium risk score of 12. To mitigate this risk, we recommend the use of proper PPE, conducting the regular maintenance check, and implementing strict safety protocol. The maintenance manager is responsible for implementing this work activity before 20 September 2023, and this action was completed. So what I can say is, by implementing the recommended control measure, we can significantly reduce the risk associated with this hazard and ensure a safer working environment. Next, I will pass to the next presenter.
So thank you, Fatin Rohaina. Now I'll proceed to the improve of the PNID for butadiene production. So next slide. So this is the overall for improve of the PNID for butadiene production. So the changes made towards the PNID were being revised according to the hazard analysis. So this is to ensure that any amendments or changes will guide the workers to operate the plant safely and according to the PNID. Based on the hazard analysis, the equipment that focuses on improving on this PNID is the reactor, cooler, and the distillation column. So next slide. So first, we improve the PNID for the reactor. As we can see in this slide, the left side is the before improvement of the PNID, while the right side is the after improvement of the PNID. So for the improvement, first we replace the temperature controller with a temperature control indicator controller. Next, we add a redundant pump at the end butane pipe streamline if there is a blockage in the feed lines. We added a pressure relief valve in the body at the body of the reactor to ensure the overpressure was released if the pressure control system was malfunctioning. Lastly, we install an alarm system which is level alarm low (LAL) and level alarm high (LAH) to ensure the operator detecting abnormal level in the reactor. So moving on to the next slide is the cooler. So the improvement at the cooler that we made is we installed a temperature control system at the streamline by regulating the flow rates to the desired set point to ensure that the temperature desired for the process was achieved. So the next slide, the equipment that we made an improvement for the PNID is the distillation column. So first we add a pressure control system connecting to the flow control system in the inlet of the streamline. This is to ensure that the feed rate is sufficient according to the pressure inside the distillation column. We added also a pressure relief valve at the distillation body to ensure the overpressure was relieved if the pressure control system was malfunctioning. We also had installed a flow control system at the top and the bottom of the distillation column to achieve the desired yield of the product at top and bottom of the distillation column. We also had installed an alarm system, same with the reactor, which is level alarm low at the L and also level alarm high at the H to ensure the operator detecting any abnormal level in the distillation column. And lastly, we install also a temperature control system in the streamline by regulating the flow rates to the desired set point to ensure that the temperature desired for the process was achieved. So the next slide is about the positive impact of the improvement on the PNID towards the society and the environment. So improvisation made on the PNID has a significant positive impact to the society and environment. So take a look first at the society. The impact that we considered is to reduce the any accident in the plant and also enhance worker safety. For instance, by installing level alarm system at the reactor and also the distillation column, it can assist the workers to alert if there are any abnormalities in the equipment. So for the environment, the positive impact it can reduce the thermal pollution, air pollution, and also minimize the water pollution. So by proper monitoring and instrumentation for the process can ensure the plant operates smoothly and reduce the production of waste of the management. So I will pass to the next presenter to present the estimation radius.
All right, thank you, Mr. Izzat Shafiq. So next we estimate how the calculation to estimate the radius at which complete destruction of a building that would occur to do an explosion involving a production mass of the 10 tons of the 1,3-butadiene. So first, we need to consider the explosive energy release and how it translates to the damage over the distance. There are three key factors which is we need to consider, which is the first one is the explosive energy of 1,3-butadiene, the TNT equivalent, and also the overpressure and the damage radius. So let's take a look of the total energy release. We know that 1 ton is equal to 1,000 kg. So 10 tons is equal to 10,000 kg. Also, the molar mass of the 1,3-butadiene is equal to 54 gram per mole, and the heat combustion of the butadiene is at 2545 kilojoule per mole. So first, we need to convert it from mass to the moles. So after the conversion, we get the moles of the 1,3-butadiene is equal to 185 mole. Then we need to multiply it with the heat of combustion of the butadiene, which is 2545 kilojoule per mole, to get the total energy release. So the total energy release, we get the value as shown below. Next, for the second consideration is the TNT equivalent. We know that the typical value for the energy explosion of the TNT is 4,686 kilojoule per kg. And the explosion efficiency is empirical with the most flammable cloud estimates varying between 1% and also 10%, as reported by the several sources. But in our case of the 1,3-butadiene, based on the literature and also the studies on the similars hydrocarbon, an empirical efficiency for butadiene is around 3%, and it is often considered reasonable under the typical industrial condition. And also the total energy from the previous slide is the 471.816 kilojoule. So we can calculate the TNT equivalent mass, which is as shown below as the formula it is. So the value of the mass of the equivalent TNT is 3020.56 kg TNT. So before we calculate to the next consideration, which is a radius, first we need to consider the scale distance before substitute into the scaling law. So based on this question, we need to estimate the radius at which complete destruction of the building would occur. Therefore, based on the table 6.9, above is the overpressure needed to causes the complete destruction of the building is usually around 10 psig and 68.9 kPa. Before we find the scale distance by using the figure 6.23, we need first to convert the overpressure PO into the scale overpressure. So we need to divide the peak side on overpressure, which is 68.9, divided with the ambient pressure, which is 101.3 kPa. And then we got the scale overpressure is equal to 0.68, which is equivalent from 0 0.7. So from this graph, the 0.7 scale over pressure, we can get the scale distance ZE is equal to 4.5 meter per kg over 1/3 1/3 Then next we can calculate the radius at the complete extraction of the building. So how to calculate the radius at the complete extraction of the building is by using the scaling law. So in the scaling law, we need the value of the scale distance and also the mass, the equivalent mass of the TNT. After we get the previous slide of the equivalent mass of TNT and also the scale distance, we can substitute into the scaling law equation and we get the final answer of the radius is equal to 65.049 meters. So that's all from us. Thank you.